Konfransımız devam ediyor. Növbəti çıxış üçün söz verilir Kristian Slavicekə. Mövzu VYANA konsepsiyasına əsaslanan 3D stomatologiya. Qeyd edeyim ki, bu məktəbin Azərbaycanda filialının fəaliyyət göstərməsi MDB və yaxın şərqdə yeganə nümayəndəlik olacaq. Bu da yerli mütəxəssislərin inkişafı üçün çox böyük bir təkan olacaq. Buyurun.
Nowadays, the digital environment, the digital app and the digital tools are growing a lot, and also in everyday life, but also in dentistry, we start to have a lot of software, a lot of tools, and we know that maybe in the future we will not have any more dental technicians that are able to work with their hands. The point is that the dentists are responsible in front of the patient about what they do, and we need some criteria, some knowledge to judge the software and to judge the tool in a proper way. Kristian Slavicek will introduce the concept that we have in our school toward the 3D dentistry. Thank you.
Yes, hello again. I'm glad to be back on the stage and will entertain you in the next hour with our thoughts about 3D dentistry based on the VYANA concept. In my introduction, I think I made clear that dentistry has to be a discipline of precision and accuracy. Okay? Therefore, we are, as VYANA, actually quite conservative to exchange immediately when new products are brought to the market. We don't exchange immediately against well-established functions and procedures, and therefore I have prepared a presentation about nowadays 3D dentistry, you know, and I mentioned that dentistry itself is most progressive with all digital technologies, more progressive than maybe other medical professions. And also, I made clear with the development and history of the VYANA school, the origin actually started with problems according to precision and accuracy, so to quality management issues. And you also know that I'm a technician, and this is for me a very regular field I have to deal with in technologies. So therefore I start my presentation with, hopefully working, no? Okay, I'm introducing to you an Italian engineer, economist and sociologist with the name Federico Pareto, and he published a principle which is called nowadays still the Pareto principle. What he says is that basically that if you have a project, that 80% of the results of a project are achieved within 20% of the overall time of the project. But this means that if you turn around, that 20% of the projects consume 80% of the time. Okay? So therefore, it is necessary in a process chain like dentistry is to carefully look to all systematics in all these processes you do. Wrong direction. Something isn't. Okay. So this means that the elimination of a few error sources in a process chain may result in an immense improvement of the final quality of the project. So this is the positive side. The negative side means that if you insert problems and errors, sources in a process chain, then it might result in enormous high decline of the final quality of the project. Okay? So therefore it is really necessary for you to understand dentistry also technically as a chain of processes. Basically, dentistry seems to be simple. The patient is coming with a concern, you make a treatment, and you have a compliance. Okay? However, that what we call treatment is actually a process chain with many, many processes. This is just some examples of it, okay? And each of these yellow boxes is an individual process, okay? And the process is defined by specifications, input, and a process which is called the systematics you do and the output, okay? What would it be, for an example? A process would be to make analog casts, okay? So you have to mix the plaster with water and put here and then and do this and do that, okay? And it is necessary that the result can be verified against the beginning. Okay, so now we know we are all human. Every process has tolerances and errors, okay? So because we are making tolerances and errors, so this is something what we have to look at. And there are two typical errors and tolerances we have. The one is the statistical error, okay? This error means that it's done by the acting person. It's done by the dental technician, okay? And over the time, it averages, okay? So this means also the better the dental technician is trained and instructed to the process, the better the quality will be finally. And statistical errors are responsible just for 20% of the problems you have in your dental office. So we call this the precision of a process systematics. On the other hand, and this is actually the bad guy, okay? We have so-called systematic errors, okay? Systematic errors are committed and is responsible of the superior person, of the doctor, okay? Or of the head of the clinic, because he is designing the systematics of the process. And these errors are not averaging, and they are healed always to one direction. Even, and all the responsibility of these problems is for 80% in your process chain. So we talk about accuracy of a process systematics. Now let's make a picture out of it. You know, the card game, okay? So you would have precision versus accuracy. This is a process which is systematically correct and provide a high precision. We are always more or less close to the bullseye, okay? So this is what we dream, okay, what we want, okay? Now let's look here, okay? So this is a process which is systematically correct, but the working people are having maybe a need for more training or whatever, so it's systematically read, but the precision is not good. So this is something what you can change in your office by training or other measures. And now we come to, again, to the bad guy, okay? And this is the process which is systematically wrong, but has a good precision. This means you are doing something every day which is absolutely reproducible, okay, but absolutely wrong, okay? So let's say, just an example, for our school, you could manage a very reproducible mandible position by hardly pushing the mandible posteriorly. So we'll always get the same result, but it's not physiologic and it's not that what you're seeking for, okay? So I think this is really necessary for you to understand. And as I presented before already, the quality management was the origin of the VYSID school of thoughts, okay, coming in touch with all the gnathology and development of new gnathology. And just repeat this picture, which shows that we really need comprehensive diagnostics, okay, to assess the patient, to come to the right diagnosis for our treatment planning. Now, all the diagnostics you see are here displayed mostly analog. Okay? And as I said, dentistry changes to digital. We have to observe how this digital world fits to our systematics of VieSID. Okay? I think this is really important, because if we would exchange and make errors, introduce systematical problems in that what's working now, I think we would reduce the quality of the result of our work, and this is not only prosthetic work, but this, in our opinion, can also harm the patient, and this is the worst thing what we want to do. So, if you analyze digital dentistry nowadays, there are several problems, but I discuss with you today the main problem which we have is that our patient still is analog. It would be much more easy if the patient would be digital, right? So we could immediately have everything in the computer and could work and then stay in the computer. We don't need milling, we don't need scanning, we can do everything, but that's not the reality. So whenever you pass the border between analog and digital, there is an accuracy issue, which is the same when you go from one country to the other, you have to pay customs fee, and in this way the customs fee is accuracy. And of course, the same way back. Okay? So we should analyze nowadays situation in several fields of interest, which are important for our school. So these are the digital study casts. Okay? We need full arch impressions. I really also like the name study cast, okay, because it says that it's something what the doctor, the dental technician should use to make a diagnosis, to make a treatment plan. We need to consider digital maxillomandibular relationship records, how this works, how accurate this system works. Of course, my beloved child, the virtual hinge axis and jaw tracking systems. Okay, we discuss this in follow, and also we discuss how to transfer digital casts, mounted digital casts, into an accurate virtual articulator system. So let's start. Let's start. So if it's our opinion only if those four fields are working accurate together, then it is possible for us to create in the computer an accurate virtual patient. And this must be the goal. This is the foundation of all our diagnostic and treatment approaches. What's this? Okay, at first we go to the digital study casts. So there are two methods available how to create digital study casts. From the mouth, we are talking about the indirect workflow and the direct workflow. The indirect workflow, as it's shown here, at first creates still analog impressions and physical models. Then we need to locate the hinge axis. We use electronic condylography. Take a reference plate, so the relation from the upper to the lower. We mount to the physical articulator. Then we use a laboratory scanner. Okay, in the laboratory scanner, we get the casts mounted to the virtual articulator. So this is called the indirect digital workflow. And it is here important to say that we have three scans. It's the scan of the upper and the lower. And then we have a vestibular scan, which mostly nowadays is done within the articulator system. Also, it is not possible to use unmounted or not mounted casts. We need special adaptation plates for the scanner so that the relation to the articulator can be implemented in the digital. So here is a publication from our co-worker and one of our senior faculty members. He published 2018 in the Journal of Prosthetic Dentistry about the, 2020, sorry, about the indirect digital workflow, and he found out that this method which we use with the scanner is, can be reliably used for virtual occlusional analysis in the clinical practice. Now let's look to the digital workflow, to the direct digital workflow. So we use an intraoral scanner. You all are aware of these instruments. So this intraoral scanner is used to create upper and lower full arch impressions, digital impressions. Then there are usable or digital face pose and recording systems on the market. Of course, we still need to have a intraoral, a reference bite, centric relation if you want to call. You use the intraoral scanner to take a vestibular scan in the patient mouth. Then you go directly to the articulator and into the CAD-CAM system for producing whatever, okay? What is here missing actually is the diagnostic step in the virtual articulator. So if we look to the distortions of the 3D scan, we have to acknowledge that also the scans on the screen are looking just fantastic and great, but are they accurate? How far can they be used in our school? And therefore, maybe it's good if we overlay such impressions. This is a comparison between a lab scan and between an intraoral scan. And if you look to this picture on this side, I just show you this type of distortions which take place, okay? You see that as the one from the other. So this makes us curious. And what we did is that we, of course, as always, we look to the literature, okay? So, and we were looking to literature which basically were in vivo only, because we don't need to look to laboratory research. We want to see how it works in the real life, in the mouth. And there was not too much, because most of the literature is in vitro done, so means in the laboratory. But the one study which is the most accurate or the most feasible now to judge is Pocket Eye from 2023. And he was using in the mouth spheres which he put, and he was measuring the distance, okay, between, okay, and he found out that especially in the posterior part of the full arch scan, there are considerable distortions, actually over different type of scanners, okay. So now you can read these distortions and can judge it for yourself if it's clinically acceptable or not. And certainly scanners are getting better every time a new version of scanner is coming, okay? But the technology behind has certain limitations, and we need to be aware, and you should probably not believe everything a salesman tells you about the scanner. They probably tell you an intraoral scanner has an accuracy of 10 microns, but what they mean is 10 microns on one crown, okay? But if you take the full arch, we are talking about 200 microns, okay, as this research is showing. So just be careful. So now, as next, we talk about digital maxillomandibular relationship. This is also an important part, because we want to get upper and lower cast into the correct position. So the workflow is the following, that at the beginning we have to, of course, create an upper and a lower digital impression. Then we still take a reference plate, or you are scanning in ICP. This is also a possibility if you choose for. And then the intraoral scanner is used for scanning vestibular layer on one side, maybe on the other side. Two sides are definitely more precise than one side. And finally, we have the relation from the upper to the lower. As I said before, on the screen it looks fantastic. However, we have to look to the literature again. What does the literature say? And there is one lady scientist, Revilla Leon, and she's publishing a lot of papers with the digital world and accuracies. And what you can see here is that she is, unfortunately, or maybe there is no other way, using in vitro studies and compares lab-scanned relations to relations gathered by the intraoral scanner. And these are the figures there she's getting out of her study, which show something like 200 microns in an average of distortions between the upper and the lower. However, there is also one more remarkable thing. What she added in another study is that she found out that actually ICP-mounted models, as you can see here, have a really, really worse accuracy than reference position models. The cause for it, I can explain. Okay, the cause is first of all that we have a lot of overlapping structures which are not clear, but there is another problem, and you need to be aware on this problem, which is post-processing. Okay, so in the moment when you are in ICP and you have inaccuracies, you have a tendency, and this is of course too much, that you are overlapping the structures. Okay, so in the post-processing process, the software then does whether repositioning the models or trim the occlusal surfaces, or it opens the virtual articulator, which is all a guess, in my opinion, because we don't know what is now the ideal thing. But what Revilla Leon found out, that we have, without post-processing, something like 160 to 211 microns of accuracy, and with unadjusted, so no post-processing, it's between 211 and 250 microns of accuracy. So also this we have to know, okay? I hope I don't destroy your dream of digital impressions right now, okay? Good, so let's come to the next topic, which is the virtual hinge axis and the jaw tracking, virtual jaw tracking. At first, we should shortly talk about hinge axis. What is hinge axis? Hinge axis, the temporomandibular joint has 3 axes of rotation. Okay? So we have a sagittal, a frontal, and a horizontal axis. Okay? And the horizontal axis is, of course, geometrically passing the both joints, and by the definition in Mosby's medical dictionary, is the hinge axis is a line that passes through the left and the right mandibular condyles and coincide with the center of rotation of the mandible. Okay? Now, there is a physical principle, okay? Because there are schools or scientists who say hinge axis doesn't exist. Okay? But physically, if you have 2 3-dimensional bodies connected with 2 joints, it's a physical principle that you must have one rotation line, okay? Because else they couldn't move, okay? So please keep in mind that a discussion about if hinge axis exists or not is, anyway, maybe too basic, okay? So, furthermore, hinge axis, if you look to it, okay, if you see the movement of hinge axis, it's not moving, very slow, doesn't matter, okay. If you see the chewing circle of a patient, okay, you can see that the hinge axis is moving together with the mandible. Okay. So geometrically seen, the hinge axis and the mandible belong together. If we see the coordinate system here and the 0 point of the coordinate system, the centric point, okay, this means this is hinge axis, yes, in a terminal position of the mandible, posterior terminal position of the mandible. Okay, here in this schematic drawing, you see that the temporomandibular joint has 3 main structures here. We have the glenoid fossa, we have the discus articularis and the condyle, and between the glenoid fossa and the discus we have a functional space which is called the upper joint space, and between the discus and the condyle we have a functional space which is the lower joint space. And if we see this old video from Westerson and Eriksson, it is clear how the joint works. Okay, if the condyle translate, the disc is going with the condyle, and you can see that in the upper joint space we have mainly translation, and in the lower joint space happens the rotation. So here is already, this was already found by the British anatomist Henry Gray. He described it already in 1897. Okay, so you see these schematic drawings. So, and it's a prerequisite for hinge axis location, is a prerequisite for axiopantographic recording. If you look to the Posselt envelope of motion, published 1952, you can see that with a control of the mandible, you can restrict the mandible from going forward, and between A and B point, you can locate the hinge axis in the joint level. So let's talk about the significance of hinge axis. Why do we need the hinge axis location? So in reference position, so in the terminal or in our 0 point of diagnosis, it is our basis of any diagnostic approach. Okay? It is the base of a unified coordinate system which we call and which we use the axis orbital coordinate system. And it is the prerequisite for instrumental analysis in the articulator. It is also, hinge axis helps us or avoids interferences during closure. So what we want, if we have changes in the vertical dimension of occlusion, we don't want any interferences, or on the other side, we don't want that the condyle disc fossa relation is compromised. You could say, if you would manufacture, for an example, a splint in an arbitrary mounted articulator, this would mean when you insert the splint to the patient mouth, this could change the position of the temporomandibular joint with the risk that the patient cannot adapt to this new situation. And furthermore, we need hinge axis to do pantographic recording because we don't want curve distortions. As we can compare the left to the right side here, this would be the same patient, probably with correct hinge axis. Here we are getting curve distortions, and here we are also getting wrong readings. This means that hinge axis is a prerequisite for accurate axiopantographic recording. And this is another picture I would like to show you maybe for the dental technicians here in the room. If you would mount the same upper and lower cast to the articulator with the same centric plate or reference plate, one time you mount it up here, the second time you mount it up here, then you remove the plate, you will think you have two different patients finally when you close, okay? So you can see the effect of the rotation in occlusion, in vertical change in occlusion, even with a wax plate, okay? So, and you probably know that if we are not on hinge axis for the pantograph recording, because the mandible movement consists of translation and rotation, we actually want to trace undisturbed the translation, but here it would be influenced and we would get readings which are actually of no use, whether for setting the articulator, nor for reconstructing the patient or making any diagnostic. So, and here is another example for pantograph recording. This would be in the middle, and if we displace hinge axis, we are getting simply different results. and different inclinations. Okay, so I think it's very important that we have to consider hinge axis as a really important part in our quality management, treating and analyzing patients. So the German Society, which was already mentioned by Cinzia, has also published in the guidelines the different type of jaw tracking systems on the market. It's maybe not complete, but I think it's okay when I explain what is my point, okay? So let's forget the intro ones, just look to A, B, C, D, okay? You can see that A is the classic axiography and condylographic recording system where we trace directly mechanically on hinge axis. B could be used as the same, but this system doesn't support adjustable face bow. And here we have Sebris optic and Sebris ultrasound system and STI matrix system. I think it's a Russian system. And here we see Mojo Ithaca system. What is the big difference between here and here? Okay, is how the sensors are mounted. Because these systems are not able to locate the hinge axis as a gold standard with an adjustable face bow. They have to use a calculated, estimated hinge axis. Okay? I guess that these systems work well. This is not the issue, but I feel that hinge axis is really of high importance. And when I refer, and the reason why we use the cardiac system, also Cinzia doesn't like this study so much, but a recent review study published by a group of Romanian doctors, they said simply in their research, in the literature search, that the cardiac device is a reliable device with high repeatability of the recordings and low mean errors provided over the time. Plus, they say that we are more or less the scientific standard. All other systems need to compete to us because we are the most accurate ones. So this is the measurement qualification standard of the cardiac system, but I don't want to go into detail so much. The only thing what I want to point out is this point here, okay? The lowest one, because we can locate the hinge axis better than 1 millimeter off real hinge axis with this method, okay? And this turns out to be really an important thing, okay? So Albert Mehl, in his publication from 2018, okay, so he confirmed, okay, in his work that the iterative method of near joint measurement setup is the gold standard to locate the hinge axis. So that with a micro-adjustable lower face bow and with paper flags, whatever, you can, in a range of 1 millimeter, find the hinge axis. This is what he confirms, and this is actually what the type A and probably type B systems could use. Okay? And he's criticizing in his work the anterior setup of sensors. Okay? He's saying that if you have just measurement accuracy on the sensor level of 50 microns, he's criticizing that you are not able to precisely locate the hinge axis, and there can be errors which are up to 20 or 30 millimeters, okay, to locate the hinge axis. And there's one more point which is really important, why I think it's really important to have the clinical experience too, because that these systems or systems working in the laboratory environment, working, I think this is very clear that these algorithms probably work, but in the reality, in your patient chairs, you might have functionally disturbed patients, or you even have patients with TMJ pathologies where this type of algorithms maybe have even more problems, okay? And he also found out if you are not able to control with your eye that you suppress like the postal seam between A and B so that you have translation, the hinge axis might mathematically very much drop down the ramus, okay? Which happens also with students of ours which are not able to locate hinge axis, which we need more training for, okay? And what happens in this case is clear. Would be the same inclination recorded on the patient, but just 10 millimeters difference make 8 degrees different setting on the articulator, okay? So you're talking maybe about a different patient, finally, when you're not precise in this work. And I need to also inform you that there are different methods proposed to locate the hinge axis. For an example, that protrusion opening translation movement curves should overlap, then you are on hinge axis. Or you are doing tooth tapping movement to find the hinge axis, or you repeatedly open close and have the tongue on the palate and things like this. I just want to warn you that none of these methods are really scientifically supported. Okay? Also, again, I repeat, if they may work in the laboratory, but on the patient side, I don't know any research where there is a support for these methods. And the consequence could be also, if we are now comparing the axiopantographic recording to other recording systems, we can see here a accuracy work of the Mocho system, which is available in the internet. You can read it, you can find it. It says in the laboratory we have plus minus 5 degrees. So now here we have the distribution of condylar inclination in a population. It's from COPS. There are more than 300 temporomandibular joints. You can see here the sagittal condylar inclination. If I put 10 degrees as a range, plus minus 5 degrees, you can see that I probably already cover 80% of all available settings for the articulator. If we compare this to the cardiac compact system, which is the arbitrary system of the cardiac line, we have from a similar study in the United States from the Tufts University, which they measured that no measurement was off more than 2 degrees. And you can see here the difference of what we think is accurate and precise should be used. Another study with Mocho comparing with cardiac compact, unfortunately compare it to the arbitrary setting, shows here in the statistics that also the study says that it's a comparable accuracy, but two things are obvious. First of all, the regression line statistically of the deviations should actually be parallel, but it's not. So there seems to be some systematic problem in the study. And secondly, if I see all the dots up and down, it is obviously that with statistics you can prove a lot, okay, in my opinion. But I wouldn't judge that to be accurate, even if I have recordings which are here up, okay? So just be careful. And one more study in this regard, which was done, is in Italy from Lebedi et al., comparing the optical Sebisch system to the cardiac system. They had 10 patients recorded with both of the system, the same patients, okay, one with the other, and also they came to the conclusion that it's a comparable accuracy. But when we look to the details of the findings of the tables, we see really totally differences, at least at 50% of the recordings. So I think we have to be careful, and it's really also what we learned is that every study which is published, we don't only read the conclusion of the author, we are looking to the data and make a small meta-analysis. And thanks to Cinzia Fornai, this is really very helpful also in our development. I want to conclude here with this section with a statement of Sir Francis Bacon. He lived in the 15th century, and he was an English philosopher, statement, and the pioneer of modern scientific thought. What he said is that truth can come only out of error, but never out of confusion. And if I translate this in my thoughts, I would say we have to know our own error. Okay? If we don't know our own error, we don't know the result, why the result deviates from that what we expect. Okay? And look when these people said that. Okay? Just amazing. So let's come to the next part, which is the digital Facebook transfer. Okay? So how we can get digital models, full arch models, into a virtual environment so that the virtual articulator is a true simulator, static and dynamic, of the patient. Because we definitely need that. So in the anatomic world, okay, we have mechanic phase bows. Here we see a kinematic phase bow, and the kinematic phase bow is taking the left and the right hinge axis point, okay, and the anterior orbital point forming axis orbital plane. The axis orbital plane is in relation to the bite fork to the upper cast, okay, and this is transferred mechanically to the articulator, okay, straightforward, okay. In the typical digital workflows, they are typically not using a phase bow, okay, so and they are not using hinge axis localization. Maybe 95% of all digital work is done taking impression, send to the lab, and do whatever, okay? And if the lab doesn't bring the result, the lab has to redo it, okay? So this is 95%, okay? Or in the lab, the models are placed arbitrarily or statistically into the positioning of the virtual articulator, or in some cases with virtual phase bows, they use a calculated hinge axis with digital phase bow systems. So the question in articulator mounting is where to place the models correctly relative to the condyles and to the reference plane, okay? Because this is what we need to analyze, okay? This is what we need to study with the case. So this is exactly what we need. I already said that. We need axis orbital plane, we need the condyle inclination, the setting of the articulator, and the correct relation to the both of it. Okay, sorry. So we are at VieSID now using digital approach where we use a direct digital workflow with exact hinge axis, okay, and this is to be introduced. In this case, what we show you, we use a Trios 5 scanner, intraoral scanner, three shape, but you can use any other, okay, this is not limited to it. The prerequisite is only that you have an open file format so that it exports the digital impression in the file format. So the advantage with our approach is that it's compatible with existing analog phase bows, anatomic and kinematic, so both can be used. We still can continue to use the gold standard of hinge axis location. The method is accurate and also inexpensive. And we don't need to buy an additional expensive digital phase bow transfer based on a calculated and computerized hinge axis. So what we use are these transfer blocks from Gamma Company and a bite fork, which has a full arch upper impression, as you can see it here. Of course, we need to make upper and lower full arch intraoral scans, and also a positioning from the one to the other, so a scan of the vestibular so that we know the relation. And here in this video you see an analog condylograph phase bow where the bite fork is mounted and the hinge axis is adjusted, and we are going to this transfer stand, which is a laboratory help tile, help part to mount this phase bow. And then we select the proper distance block, which gets inserted in this articulator simulating transfer stand, which closes down and keeps a certain gap, okay, which we need here, okay. It should not be too big, it should not overlap, it should be something like 10 millimeters or 5 to 10 millimeters opening. In the next step, we have to fill with a simple putty material the optical bridge with material, as you can see here. Okay. So, like this. And what we also do is that we are making some additional impressions here on the putty material with a pen, for an example, so that we have more not too flat surface on the putty material. And after that process, we are taking the intraoral scanner and we are scanning this situation. It is important that we have the geometrical parts of the block and the bite fork, as you can see here in the scan. So now we are scanning this situation. On one scan, I see the block and the impressions. Okay? The putty material is just an optical bridge, is of no importance. So the result look like this of the intraoral scan. Okay? So you see that? Okay? And by the way, the same method also works with the anatomic phase pose system. We can do the same here and also make a scan directly with the anatomic in the articulator, receiving a similar situation. And then we can align, we can export, for an example, this information to ExoCAD software where we can make an alignment process, or we can use our own software to do that. So at first, we are matching the transfer blocks. So we have a transfer block we know geometrically in the articulator, and we relate it to the transfer block of the scan. Okay? So the matching is happening here. Okay? And the second matching process is done then that we have the impressions of the upper, and we match it to the upper arch. Okay? So I have it here. And of course, the lower arch is connected to the upper, so it automatically moves. So, if you see now, again, we have the bite fork scan, we have the intraoral scans, upper and lower, and we have the articulator with the block. Of course, the block B must be the same like on the scan. The first thing is that we match the bite fork in the correct position, as you have seen here. And the second one is that we are matching the models in the impression. Okay? Pretty straightforward, not magic. Every dental technician can do this easily. So that we getting this result and the transfer is completed. Okay, this poster, this was proposed at summer school on a poster, this method, and it got the second prize, right, for the best posters at the time. Okay. So we also experienced, or we were looking to our own accuracy, so we make tests in our laboratory, and we find out that on the occlusion level, this method has a maximum error of 0.16 millimeters, so 160 microns, okay? By positioning the upper, the lower, and on the joint level with the trios, we are a lot better. We are something like a little below 300 microns, and with the Medit scanner, which we also tested, was something like 700 microns. This sounds now a lot, okay? But don't forget, we are not changing the relation from the upper to the lower. We are only talking about the precision and the accuracy to put it into the virtual space of the articulator. Okay? So, and therefore, we are still with this method better than the gold standard of 1 millimeter of hinge axis location. So, therefore, we say that this method is acceptable, especially if we compare to, again, other studies, which is a study from Lin and Al from 2023, he or she, I don't know, compared different methods, okay, of mounting to the virtual articulator. And what he or she found out was that the best accuracies could be reached between 2.8 and 10 millimeters of distortion from the true hinge axis position. Okay, this is my conclusion on the mounting, okay, so that I think here the most important thing for us as a school is that we can easily transfer this method from a didactical point of view into our systematics. Okay, this is important for us in our school in VieSID. The students need necessarily to learn how to locate hinge axis, how to understand the systematics in a mechanic way. If they don't and immediately jump into electronic systems, they are caught by mathematical principles and things which they cannot judge. What is good, what is not, so they are maybe in the foggy area of confusion. Okay, and this is what our school wants to avoid. So now just let's talk about, and I'm coming to the end of my presentation, why are we doing all this? Okay, so why are we making all these efforts to think about what we can do? And the reason for is that we need it for an exact digital instrumental analysis. Instrumental analysis means that we are doing an analysis in the articulator, regardless if it's analog or digital articulator. And if it's a digital, then we need to be exact the same way as the analog, because because finally we want to have an exact pre-planned digital occlusal design, which is necessary, which I cannot show you too much today because it will exceed the lecture time. But what we need are different tools in the virtual system which can be compared to the analog world. So we need, of course, the possibility for graphical numeric analysis. We need to have occlusal protocols. We need to see the sequences of contact. We want to see how the guidance system in occlusal works. We want to compare and overlay to other digital methods like the CBCT, and maybe also to analog things like the Brax checker or the occlusogram. We can overlay it nicely, but finally also we can do occlusal design in the treatment phase, or also mandibular repositioning the models if the case is necessary for this type of techniques. So, this died. Okay. So again, our invitation to summer school. I'm coming to the end of my presentation, and I would like to thank EFO again for making this possible. I hope this information was somehow helpful for you, and I'm really open for any kind of discussions. And thank you so much for your attendance.
Kristian Slavicekə sertifikat təqdim etmək üçün Azərbaycan Elm Universitetinin Ortodontiya Kafedrasının müdürü Ramidə Şadlinskaya dəvət edirik.
Hörmətli kollegalar, sevimli tələbələrimiz, çox dəyərli qonaqlarımız, lektorlarımız, bir daha sizə hamınızı burada salamlayıram. Qeyd etmək istəyirəm ki, son zamanlarda tibbdə müalicəyə holistik yanaşma çox populyardır. Ortodontik müalicədə də holistik yanaşma çox öndə olan müalicələrdən biridir. Bu da bizim tərəfdən okkluziya tək bir problem kimi yox, ümumi orqanizmin problemi kimi yanaşmağa kömək edir və ümumi pasientlərimizin həyat keyfiyyətinin yaxşılaşdırmasına kömək edəcək. Bu baxımdan düşünürəm ki, konfransımız çox faydalı olacaq və cənab Kristian'a bir də öz təşəkkürümü bildirirəm. İnanıram ki, bugünkü əldə etdiyimiz biliklərimiz bizim praktikamızda da öz töhfəsini verəcək.
Thank you very much. Okay. Thank you so much.